coming to this session where we're going to talk about progressive delivery in the Kubernetes era. So, of course, we're going to see a bit of things of Kubernetes, or we're going to use Kubernetes tools to implement progressive delivery. Maybe you don't know exactly what is progressive delivery yet, but no worries. We're going to answer these questions in the next slides. My name is Alex Soto. My Twitter is AlexSotoB. My email is soto@redhat.com. Sometimes people ask me, can I send you an email? And it's yes, for this reason, it's here the email. If not, I will just remove it from the slide. So just send me an email if you've got any question. And well, basically, I also am the author of these books, which, if you like the session, there is this GitOps cookbook where we are going deeply on some of these concepts. So today's objectives is like, let's see, what is progressive delivery? What are the delivery techniques? How to implement these techniques in Kubernetes, and finally, the conclusions. So, what is progressive delivery? Okay, then basically, the first thing that we need to know is where is the progressive delivery part fits into the common continuous integration, continuous delivery pipeline. We know that we've got the continuous integration pipeline where we build the project. Probably we run some unit tests, some component tests, maybe some kind of end-to-end test to validate that what we've built is correct. Then we make some security checks, static analysis code to check security issues, null pointers, things like that. And finally, we release the application. And when I say here in the context of continuous integration, release is just taking this build, this package. In the case of Java, maybe it's a jar file. In case of Kubernetes, it's a container image. And we release to an artifact repository. For example, Artifactory, Nexus, or if you are in the containers, any container registry, like for example, Y or Docker Hub. So this is the continuous integration part. And then it comes the continuous delivery part, where we deploy, for example, to staging environment, and there we run the full end-to-end test, some exploratory tests, well, whatever you decide. And finally, we deploy to production. So it's just like, okay, it seems that everything is working as expected. Let's move it to production. And what is the progressive delivery part? It's here. It's just after the deploy to production. So we deploy to production, that's fine, but then it comes the progressive delivery part. So it's what's going on after the deploy the application. Basically, with progressive delivery, we are avoiding the big bang effect. So instead of deploying the new version to your cluster and say, okay, let's just start sending all the public transfer traffic to, let's transfer all the traffic from the old version to the new version, let's do it and see what's going on. And maybe there is some failures or, some regressions. And instead of getting the failure to all your users, what we want to do is limit the scope. So as you can see, we are in small steps, step by step, starting moving the traffic from the old version to the new version. We're doing progressively. One other thing that it's really important is to keep in mind that now deploy and release, it's not the same. Well, if you've been in the development for some years, when we've got this big monolithic application, we just said that we're going to deploy to production or we're going to release to production. We can say that both concepts was kind of the same. So we can just say deploy to production, which means take the monolith and deploy it to production, or release to production, which is take the application and move it to production. But now with progressive delivery, both concepts are different. One thing is deploying to production, which means take your application, put it on production cluster. For example, your Kubernetes cluster. But you are not releasing, because then we've got the release process, which is start sending public traffic to this new version. So you can deploy your application to production, but nobody will never reach it. But it's there, it's in production. And then you will start the release process, start sending public traffic to that new version. If you start doing in this way, what is really, really important is getting the metrics correctly set. Why? Because now it's super important to know if your new version is working as expected or not. How you can know that? By measuring. And you can measure using metrics. So now metrics is really, really important because it's what they tell you if your application is working correctly and you can start or increasing the release process or stop it. And finally, just as maybe as a summary, it's like, as I've been saying, instead of sending the whole traffic to all your users, you are just selecting a subset of your users and sending the traffic to the new version. So, and a small portion of your users will go to the new version, they will test your application, and the other, maybe the 99% of your users will still going to the old version. Thanks of these strategies, we are decreasing the downtime in case of an error. So if you've got a regression and everything goes down, it will only affect this small portion of your traffic, this subset of users. So you're limiting the tragedy. So now instead of saying, okay, I'm going to release my new version, I just put my new version on production. Oh, there is a regression. All the users see this regression. In this case, it's not all users, but just a small portion. And also, this helps on putting your application in production faster because, okay, you can start getting these strategies, then you will get confidence of you're doing the things in the right way, and you will start deploying to production, releasing to production faster and faster. So, how many delivery techniques are out there? Of course, there are a lot of techniques under the progressive delivery part. You can find it if you Google it, you'll see a lot. I will explain you here the most common ones. I would say that most of the people who I've been talking about it, these techniques that they are using in their companies, they are using one of those, but of course, there are more. The first one is the blue-green deployment. Probably, I don't know if most of you already know what is blue-green deployment. It was super, a technique used especially when we got virtual machines, right? When starting a virtual machine takes a lot of time, deploying to a virtual machine also takes a lot of time. So what we wanted to have is something like a blue version, which is the old virtual machine with the old version of your application, and you were sending all the traffic to this virtual machine. And then at some time, you wanted to update that application, so you created a new virtual machine with the new application there, and you reroute the traffic from the blue to the green version, right? So it was a all or nothing. So all the traffic goes to the blue, and then you send all the traffic to the green. Of course, as I said, this was really important during the virtual machines era. Now, with the Kubernetes, okay, you can still do it, but probably it has not much sense. But it's a technique that has been here for a long, long time. And one of the great things about this technique, something that made me think about it, is that with a blue-green deployment, you are not deploying a new version by destroying the old one. You see that both of the versions live together. You've got the blue, then you deploy the green, then you release the green, and the blue keeps in deployment state. Not in releasing state because you're not sending public traffic, it gets in the deployment state. Why? Because if you detect an error to the green one, you can just do a quick rollback from green to blue, because both versions are still deployed. They are not removed from the cluster. Another one that is much, I would say that is much better, is canary releases. Because you know, what's happening if you've got a regression in your new version? You're just sending all the traffic to version 2. All your users will get the error. And okay, we need to go to version 1, which is going to happen really quick, that's true, but all your users will get an error. And this is something that maybe you don't want to happen. So we've got canary releases. So instead of sending all the traffic to all the users to the new version, we are just sending in a small percentage. So for example, we can say, okay, now I'm going to send 90% of the traffic to the blue and 10% of the traffic to the green. And see what's going on, see if it works. Now you will start monitoring the green one. If you see that, okay, it's working, right? There is no regressions, the performance is okay, there is no bugs, everything works. Let's increase that percentage from 10 to 15 to 20, 25, 30, 50, 75, 100%. So instead of moving all the traffic from V1 to V2, now we are just doing step by step. And this is a canary release. Okay, it's a really nice technique, but also it has a problem. And it's like, what's happening if I have like 1,000 users per second, and I'm sending just 10% of these 1,000 users. It means that I'm just sending like 100 users to the new version, and if there is a regression, 100 users, so the 10% of my users will get a bad experience about my new version, about my application. So Google, Amazon, and these big tech companies decided that it could be a good idea to create one thing that is called dark launches. Dark launches is a set of techniques that basically what they try is to test your application in production, but the user will never notice that. Okay, and there is, as I said, a lot of techniques. For example, mirroring traffic. Mirroring traffic, it's this one. Okay. Basically, what we are doing is I have both versions on my production cluster, the green and the blue. The blue is the old one. And when I send a request, I send both requests to the blue and to the green. Now, both services receive the request, they process the request and send a response. But the only important response, the response that is going to be sent back to the caller, is the one from the blue, so from the old one. Okay, and the green one, which is the new version, is going to be a fire and forget request. Just send the request and I don't care about the response. Why this is important? This is important because now I can monitor blue, I can monitor green for the same request. And if I get, for example, a performance regression or a different kind of response, for example, the blue works and the green gets an error code, it means that, okay, it seems that the green one, the new one, it's not behaving exactly how I expected. So I'm not going to do a canary release or a blue-green deployment. I'm just going to stop green one, fix the problems, and start again. So as you can see, your users, all your users that are accessing your application, they are on the old one. They will never notice that you are using their traffic, their data, to test the new one. Another option is using a dark canaries. Dark canaries is something that it's used, for example, for use it in Facebook. I will explain you in a few moments. And basically, it's this schema where it's similar that you can think it's like kind of canary release, but now instead of sending the traffic depending on a percentage number like 10%, 15%, 20%, and so on, you are just setting a flag. In this case, for example, test equal true. So, for example, if I send a request and this request has a special header, for example, an HTTP header that says test equal true, then I'm going to send the traffic to the green one, so the new one. And if not, I'm going to send it to the blue one. How this is used in Facebook? Okay, I don't know if you know that the release process of Facebook, it's quite complicated, okay? But what they do is that when they, I think it is every Tuesday, they release a new version of Facebook. And when I say a new version of Facebook, I mean a version with new features. Then what they do is, before that, for example, on Monday, they make that all his employees, all people that is working in Facebook, when they access Facebook, they access to the new version, so the version that is going to be released. Okay, so instead of saying test equal true, we're saying is that if your user ends with facebook.com, then it means that you are a Facebook employee, so let's test the new one. If not, the rest of the mortals, they go to the old version. So it's that the employees of Facebook helps to improve Facebook itself, okay? Of course, this is an example of Facebook, but you could just, for example, create this kind of flag like test equal true. And if you've got a QA department, you can say, okay, we are going to deploy to production, and then when you access to the service, just set this flag to test equal true, and you will start testing the new version when it's deployed in the production cluster. So one of the key points here is that if you notice, you are start doing something that is called testing in production. So be aware of telling this to your manager. Because if you say, yeah, we're going to use production clusters for testing, it will say, oh, no. You cannot do this kind of things in your production cluster. Let's see that if we break something, right? So you just explain what is a canary release and what is a dark canary and so on, but don't mention that this is testing in production. Because when you start doing testing in production, you are starting saying that production is not sacrosanct anymore. Because you are start testing things. You're just deploying your new version. Remember, deploying, not releasing, and then you are start testing it. And in the production cluster, which is where you should run all the tests, because you know staging clusters are not the same as production clusters, because there is DNS, firewalls, and things like that. So it's a technique that I recommend you to use. Test in production, but be aware that sometimes things cannot work very well. In fact, I like now when we are talking about testing in production, because progressive delivery is really tied to testing in production. I like to show these columns. I like to call the new testing parameter. Here in the blue column, okay, you see the pre-production test. That's the typical test that we've been using for long years, like unit test, component test, static test, coverage test, acceptance test, mutation test, penetration test, and so on. Okay, that's the test, the kind of test that we run before we deploy and release our application in production. I like to say that this kind of tests are tests that you should be able to run on the development machine. So obviously, I'm not saying that it's not going to cost you a lot of CPU and memory, but unit tests, component tests, coverage tests, this kind of test is something that you should run on your development machine, and that's a pre-production test. Maybe not in your development machine, okay, then in your Jenkins or your Tekton or your Circle CI or whatever CI system you use. Okay, so it's a test that run on that environment. But then we start the testing in production part. And you see here that says deploy, and that's the green. So these are tests that you run when you deploy your application to production, but you are not releasing. Remember that deploy and release, it's something totally different. What we've got in the deploy side? Integration test. Some people ask me, whoa, integration tests in production? Yes, of course. Why are you running your integration test against a database that is empty, that has been started for the purpose of the integration test, that maybe just contains some few data? Why you're doing this? It's not real. that's not the real integration. The real integration happens in the real database. So running them there. For example, also tab compare, load test, shadowing, and config test. All this kind of tests goes when you deploy the application. Remember that if you detect something at that phase, it doesn't matter because you are deploying, you are not affecting your users. Then we've got this, I don't know, it's brown, yellow column, which is the release phase. So this is when we say, okay, it seems that everything is working as expected. Let's move on and let's start sending some public traffic to this new version. And you can just do the canary release that I explained, the dark canaries, monitoring, future flagging, exception tracking, future graduation, these kind of techniques. And then, and this is something that also has changed a lot thanks to progressive delivery and microservices architecture, is that you are also testing your application after you have released the application. Usually, in the past, when you were in production, you release your application in production, you're sending all the traffic there, you stop testing it. It just, okay, now it's working, let's go to the next version. Now, with this new parameter, you are also testing after you release the application. You can see that, for example, team, profiling, logs, chaos testing, monitoring, super important. Now it is something new, right? Monitoring is the new testing, you can say it in that way, because it's really important to know every moment what's going on with your application. A/B testing, tracing, auditing, on-call experience, and journey tests. All these tests is something that you should run, but run it after you release the application. And this is an example of monitoring, and I took from Netflix. Because usually when we think about monitoring, we think about monitoring the error codes, the response time, I don't know, the number of instances of the application, things like that, right? But it's really important, especially when you start doing progressive delivery, to monitor or to get metrics also from the point of view of business. Because at the very end, everything is about business. And what is this thing? Okay, this is the number of times that a user clicks play button in Netflix. You see that there are like, so this is during night. So for example, at 3 a.m., probably nobody at 3 a.m. is connected to Netflix. And this is, I don't know, for example, it could be like 10 p.m. when you know, after dinner, you just want to watch some series, some movies. So you just start, a lot of users start doing play buttons. And if you see closely, there are like two graphs, the red and this is the black one. Why? Because the red is the old version, the black is the new version. And they just start sending traffic to the new version and to the old version. And you see that the graph is more or less similar, which means that you're getting the same amount of plays for the version 1 and for the version 2. So both versions are working correctly. What happened if both graphics were different? Suppose that in the black one, there are not as much plays as in the red one. It means that the new version probably is not working as expected. Maybe there are some kind of errors, whatever. So you should stop the progressive delivery or the delivery part. For this reason, I would like to show this, because when we think about metrics, usually the first thing that comes to our mind is just checking the HTTP codes. And if there is not a 500, then that's fine, it's working. And most of the time, it's more like a business metric. So we've seen all these techniques, and you might say, oh, Alex, yes, it's quite interesting, these techniques, but how implement this in Kubernetes? Because I know that there are some things that maybe I should code them in my application, right? And I don't want you to implement these techniques into your application code. It's not the correct place. If we've got Kubernetes, we should implement it in Kubernetes. So how you implement a blue-green deployment in Kubernetes? Okay, you just need to create a Kubernetes service. You know that the Kubernetes service has the concept of selector. This is where you decide where a Kubernetes service should send the traffic. In this case, I'm saying send all the traffic to the pods that has the label in service equal my pods. So as you can see here, I've got my deployment, and I'm just getting, and in the template, I'm just annotating this version 1 with IPP my node. Since this is IPP my node and this is in service my pods, these Kubernetes service are not sending traffic to this deployment. Then the only thing that I need to do to start sending traffic to this new deployment, so to implement the blue-green deployment, is just do a kubectl label pod -l, for example, app my Python, which could be this one, in service my pods. Okay, so I'm just adding a new label. So I just kind of start playing with the labels, right? Saying, okay, label in the deployment, this my node deployment, I'm just going to add the label in service my pods, and then this Kubernetes service is going to start sending traffic to this one. Then if I deploy a new version, I just annotate it with this label. I've removed the label from the old one, and I've implemented a blue-green deployment. Yeah, it's a technique that probably I will not do that in that way, but it's the way that Kubernetes offers if we are not using anything. How about canary releases? How we can start sending, for example, 75% of the traffic to the old version and 25% of the traffic to the new version? Okay, you might say, yeah, I can use Nginx and put it there in Nginx and things like that. Yeah, okay, you can do it. Or you can just, create 3 replicas of version 1, 1 replica of version 2. And as you can see here, you're sending the 75% of the traffic to version 1 and 25% of the traffic to version 2. And then you can just, play with the replicas. It's something that I don't like it so much, but it's what Kubernetes offers us nowadays. But what if I could tell you this, that you could have a YAML file, then I can say, look, I've got a service that is named recommendation, and then this recommendation service has 2 versions, version 1 and version 2, and I want to send 75% of the traffic to version 1 and 25% to version 2. I just do a kubectl apply of this YAML file, and it works. Then, when I want to move from, for example, 60/40, I just need to edit this YAML file, change the weight from 75 to 60, from 25 to 40, I apply it, and we've got it. What about shadowing traffic? What if I told you that if I want to send, remember shadowing traffic was sending the same request to 2 versions of your application, and the first one is the normal request response, and the second one is like fire and forget. How I can do that? Okay, I could do it in this way. I can just say, hey, the service recommendation, I want to send the traffic to V1, and I want to mirror to V2, right? And it's just a YAML file. Easier than, okay, we can just, I don't know, for example, modifying your code to do that logic. How about jar canary? Remember, that canary is when you want to, depending on a header, sending the message to one service or to another one. In this case, I'm saying, okay, I have the service recommendation. If there is a header named end user, which is exact Alexandra, so I'm just setting, if the user that is connecting to this service is Alexandra, move to version 2. If not, move to version 1. Okay, it's just a YAML file, super easy to implement, right? Kubectl apply of this YAML, and it just works. And if you're wondering yourself, is this possible? The answer is yes, and it's possible thanks to Istio. Istio is a service mesh that you can install on your Kubernetes cluster that lets you do a lot of things. I would say that if you are into the microservice architecture, please start adopting Istio because it's going to simplify a lot your life. For example, what lets you do Istio is intelligent routing and load balancing. Basically, it lets you implement all the YAML files that you've seen before. It lets you do smart kernel releases, dark launches, mirroring traffic, and so on. It lets you implement all these things with just applying a YAML file. But it's much more things. Remember, you can use Istio for chaos engineering, for resiliency, for observability. Remember that we said that the metric is a key point in progressive delivery, and Istio provides with you transparently all the observability things like metrics and tracing without doing nothing. Just install Istio and you will have a Prometheus and a Grafana and a Giga server installed on your cluster and automatically provided with all the data, with all the network data. And if you say, okay, yeah, that's fine, but we are going to release, not using kernel releases nor dark launches, we're going to continue releasing as we have done all our lives. So I do not need Istio. Well, yeah, you might be right, but with all the Red Hat customers that I talk with, they always tell me the same. They say, hey, look, Alex, we've just adopted Istio because of security. Because service mesh and Istio improves a lot the security of your microservices architecture. Keep in mind that you can use HTTP to connect your services, but Istio will doing without, transparently, by default, encrypting your communications. All the certificate authority management, revoking certificates, all these things going to happen automatically by just having Istio. So your service can think, right, because it's programmed, it's code using HTTP, that the connection is going to be in HTTP. But Istio will transform this request from HTTP to HTTPS automatically. And okay, this is a big win when you are, interested or you've got concerns about security. So if you don't know exactly what is Istio and so on, I recommend you that you take a look. Because Istio works with the concept of sidecar container. Basically, it works in this way. We've got our pod with, that the pod can have one or more containers. Then you've got one container with service A. This service A is your business logic. And then it has a sidecar container attached to the same pod that basically intercepts all the network traffic. So all network traffic goes through these sidecar containers and applies, for example, the kernel release or encrypting communications or the mirroring traffic. And as you can see here, when we want to do a request from service A to service V, from the point of view of the developer, it's going to do an HTTP request to the service V. But what's really going to happen when this is executed is that service A is going to communicate with its sidecar container A, so this one. This sidecar container A is going to send a request to the sidecar container V, and this sidecar container V is going to send a request to service V. Then, when the service V gets the response, it's going to the response go to the sidecar container V, sidecar container A, service A. Okay, this is how Istio works with this sidecar container, intercepting all network traffic and applying changes to it. So now it's time to see a demo about progressive delivery and Istio and so on. And I will need your help. If you want, you can scan this QR code and you're going to move to a super website. Yeah, let me, sorry. Let me open it here as well. It's exactly the same, Babel index. And probably if you're in this website, you will see something like this. It's just these red bubbles that are moving. Now, let me show you. This is the application. I've got the Babel front end. Maybe I need to be bigger. I've got here the Babel front end, which is this one. And the Babel front end calls Babel backend v1 or Babel backend v2. In this case, the red one is v1. So it's just sending all the traffic to v1. What's happening if I want to do a blue-green deployment? So now we've got Bubble backend v1 deployed and released, and Bubble backend v2 deployed but not released. Now, let me do a blue-green deployment. I'm just going to get back, to send the traffic from v1 to v2. And this, I think that it's in Bubble's backend, source main Istio. And the file is this one. Virtual service, this one, no, this one. Okay, now, as you've seen, this is the file that we've seen before. There is a Bubble backend service, there is a version 1, there is a version 2, send all traffic to version 2. Now I can apply this file, which is this, and by just applying this file, so I'm just doing now a blue-green deployment. Pretty much better than just playing with Kubernetes labels, right? If I go back to here, now you see that the bullets are blue. Okay, it's the new version, the version 2. But see that version 1, it's still there. It's deployed but not released. Now if I detect any change, I can do kubectl apply -f virtual service v1, v2, so I'm just sending all the traffic back to v1, and there we go. All the bullets again are red. So it's a matter of just, applying a YAML file that I'm just sending traffic to v1 or to v2. Then what else I can do? Let's do, for example, a canary release. I can do a canary release by doing the next thing. kubectl apply -f virtual service, for example, 75% to v1, 25% to v2. I'm going to apply it, and I'm going to show you here the file. Obviously, it's similar. I'm just saying version 1, 75, version 2, 25. And if I go to the demo, okay, then we will see that there are some red, most of them are red, and there are some blue, balls there appearing. Okay, now I can just say, okay, I'm happy with this. Let's change something more. Okay, I'm going to apply the following. Wait, first of all, let me copy this. Open Safari. So this is Safari. Okay, now it's exactly the same example. Nothing has changed. Wait. I can even, I can leave it here. And now I'm going to apply the following file. Virtual service, mobile backend v2. Now, here I see that it's blue all the time. What I want you to see is if you are in the mobile, so if you scan the QR code, what bullets are in the mobile phone? If they are blue or they are red? Blue? Are you using Chrome or Safari and you see blue? Okay, yeah. So you're not using Chrome. Anyone with the mobile is using Chrome? Yeah, and it's blue? Red, right? Yeah, it's red. So you can see that depending on the browser, you get it the blue ones or you get it the red ones. And I've done it in this way. It's exactly the same as before, but now it's a bit more smart. I'm just saying, okay, look, there is a Bubble backend service. If they've got the header, the HTTP header user agent following this regular expression that it's like, okay, the user agent has something Chrome, right, in the value, then send it to v1. For the reason I asked it if you were using Chrome or not. If not, route to v2. For this reason, if you are not in Chrome, so in Safari, you see that the bullets are blue, but if you are with your mobile and you're using Chrome, then they are red. In fact, here you can see that in the Chrome they are red, while in the software they were blue. And it's thanks of this. So I think that implementing progressive delivery in Kubernetes with Istio is something really easy. Just apply YAML files. Now let me undeploy this version. I think that it's the clean one. Now I'm just, just getting the old version, and I'm going to deploy a new version because it takes a bit of time to deploy it, and I want to run it while I show you more things. Yes, I think that's the thing. Now, let's go on with the slides, because the most question that I get asked when I do Istio sessions is, oh, that's pretty nice, these YAML files with 75-25, 60-40, 50-50, and 25-75, but can I automate this process? Because I need to just create a lot of YAML files and just apply it when I want. Maybe I need to just, BI, take the YAML file, change the number, apply it, and so on. And the answer is not. You can also automate this rolling update, this progressive delivery, using Argo rollouts. Argo rollouts, it's a Kubernetes controller that offers you a new CRDs for implementing this. So basically, you as a, let's say, as a operations guy, you just do kubectl apply of one CRD that is an Argo CD, and he automatically do this progressive delivery. And basically, Argo rollouts connects with Nginx or Ambassador or Traffic or Istio to update these files. So these files are updated automatically, and just has a new object called rollout. Okay, so now when you deploy your application, you're not using that deployment file anymore. You're using one file that is named rollout. And what is that? One of the great things about Argo rollouts is that automatically gets data from Prometheus, Datadog, there's a New Relic, all these monitoring systems. You can just configure it to read this data from the monitoring tools and decide if it should continue or increasing this percentage traffic or roll back. So it's something that you can do it manually, or you can leverage to Argo rollouts to just monitor automatically the application and decide if the delivery should proceed or not. And basically, the only thing that you need to do is this. Apply a rollout where you say, look, I've got here a rollout. It's not a deployment anymore, but the fields that you put it here are exactly the same, metadata, containers, and so on. But it offers a new part of a file. In this case, it's specific to Istio. If you're using Nginx, it's going to be another format. If you're using Ambassador, it's going to be another one. And in this case, basically, you're saying, look, when I deploy a new version, for example, the version 2, I want to do a canary release, okay? First of all, setting the height to 20%. So I'm going to send 20% of the traffic to the new version. And I want you to do that for 1 minute. So during 1 minute, you're going to stay there monitoring if the new version is working or not. If after this 1 minute, everything works as expected, I want you to set the new version to 50. So you're going to send 50% of the traffic to the old one, 50 to the new one, and wait 2 minutes. So we're going to just wait 2 minutes, and after 2 minutes, it will finish the rollout by sending 100% of the traffic to the V2 and 0% to the V1. And as you can see here, you're just setting the virtual service. You remember the YAML file that I set it, or I showed you that you were setting 75, 20, 50, 50, 0, 100. This is where you set which is the YAML file that you want to keep updated by Argo rollout. So let's see exactly the same demo as before, but using Argo rollouts. Now you see that I've got the bubble frontend and the bubble backend. This bubble backend is the version 1, and probably if I'm going here, you will see that this is red, so it's the version 1. Now I want to deploy a new version. Let me show you this command, kubectl argo. This argo is the Argo rollouts plugin for kubectl, and I'm just saying, show me the rollouts. And in this case, it's saying, okay, there is only one version. You see here it says the revision 1, which is stable and it's ready, and you know it's deployed, so on. Now let's deploy the new version and start the rolling update automatically. I'm going to do cd argo rollouts, and I'm going to call this a script. I'm going to show you. This is just a shell script doing nothing super interesting at all. You see that it's just okay. Export that. It's just saying apply this file, and if you want, I can just show you this file. Okay, and this file, it's the one I send you. 20% during 1 minute, 50% during 1 minute in this case. This is the issue information. And then here is the part that I said you before, that it's just a common deployment fields, right? Like the container, the environment variable, image pool policy, the ports, and so on. Now, you see that now it's running and it's progressing, which means that what that means is that the application, it's, come on. It means that you see that now there is bubble backend 2.2, bubble backend 1.2. Basically, it says that the version 1 is deployed and the version 2 is being deployed. Since, remember that I said that Istio uses the sidecar container concept, now you see that there are 2 containers running, and sometimes it gets like 30 seconds to boot up the Istio container and update all the service mesh. So let's wait for some seconds. Now you see that it's healthy. You see here, it means that everything is running. And if I do kubectl get pods, you see that everything is working. And the revision 2, it's rollout in post. It means that it's this 1 minute that I said before. Now if I go here, you'll see a lot of reds and some blues. Okay, it's doing the rolling update automatically. Now, if I do kubectl, oops, not here. Kubectl get virtual service. Okay, now that you see that something happened. Basically, it's that it changed the percentage automatically. Now, if I do a kubectl get virtual service, which one? Bubble backend -o YAML, you see that now it's 50-50. Remember that I said that the first one is 75-25, then 50-50. So now you see that what it's Argo rollout doing is just updating this YAML file. It's just doing this. It's not doing any kind of magic. It's just updating the field for you. Now let's wait this minute. Well, now there are going to be more or less the same blues and the same reds. And if we wait this minute, you see that still about revisions, you'll see that it will finish and remove the revision 1 in front of the, now you'll see that now it's just happening. And if I do a kubectl get pods, not yet, see that, not yet. Now it's delayed, and well, this is easy to know. If I virtual service bubble backend, now you see that 100% of the traffic goes to the version 2 and 0 to the version 1. And you now see here how it's scale it down and remove it. So revision 1 is not here anymore. If if I'm going here, all the things are blue. And I've not done anything. It just automatically happened. Now let's bring down. First of all, I know that some of these things that you've seen here, like mirroring traffic or this, maybe dark launches, like you can have here an attribute like user agent or test equal true, or I'm an employee of Facebook, so go to the new version, if not go to the old version, and so on. It's really nice, but remember that this was just a stateless application, and state is always hard. So I would say that if you have no experience on progressive delivery, start with stateless services because they are easier, and then step by step move to the stateful services. In these cases, distributed caches like InfiniSpan or Redis are your friend. As I said, go a step by a step. Don't start doing, I'm going to do all the tests. You remember this, the 3 columns of testing in production? I'm going to do all the things at once, all kernel releases, dark launches, everything. No, because probably you're going to fail. So I recommend you that start step by step, just, an easy service, and then move on. Embrace GitOps. All the things that I've shown you here is just about YAML files. So I recommend you that adopt GitOps and make everything easy to apply, but also easy to revert. So if you want to go to the last version, just do a git revert and everything goes to the previous state. And I really like this quote, is that if you haven't automatically destroyed something by mistake, you aren't automating enough, right? So this is something that it happened to me. Like when you are, in testing in production, it's like, oh, yeah, something, maybe I screwed something. Okay, let's see what's going on. I remember reading an article of an online shop that they send, I think that they sent to a customer like 100 washing machines. And the thing was that they were just running an integration test and against the production database, but then they don't know exactly how this thing proceeded with the checkout, and they send it 100 machines to one of the customer, right? So these things can happen, but it's part of the life. And finally, if you want to just learn about Istio, there is this nice tutorial, the end.dev/Istio tutorial. And if you want to run these examples, they are in github.com/Red Hat Developers Demos, Bubbles, Progressive Delivery. And yeah, you will see all the scripts to deploy it, and also, also using Knative if you want, using Argo CD, Argo rollouts, Istio, and well, everything is there and it's explained. And that's all. I don't know if there is any question. Yeah, the question is if this is supported by OpenShift. Yes, I'm just running in OpenShift. In fact, my cluster is this one. I don't know if I'm logged in, but yeah, it's OpenShift. Yeah, everything now it's running in OpenShift. But everything that I've been using in the demo, you can just start your Minikube, your kind, or whatever, and it just works as well. I'm not using anything special that only works in OpenShift. It's just the upstream projects that I'm just using, but I'm have this my OpenShift cluster as a Kubernetes platform for running them. So is Istio a free software or it's like package we need to buy it from? No. Istio is an open source project that you can just install it using, for example, the Istio operator or applying one YAML file. But if you already have OpenShift, you can go here to operators. In this case, I've already installed, but you just need to, you see here the Red Hat OpenShift Service Mesh. It's just Istio wrapped for running in OpenShift for the security issues that you've got, with the permissions and things like that you've got in OpenShift. It's just like this. But at the very end, it's just Istio. Hi, welcome. How complex it is to install Istio? Just in OpenShift or in general? In general, it's just applying one YAML file. Yeah, there is also one tool that is called istio-curl, that you can do istio-curl install, and you put some parameters, and then it's install istio there. Yeah, it's not hard. Yeah. You need to be cluster admin, right? For this reason, for Minikube and kind and so on, it's easy. If you are in the OpenShift, we offer this operator, which it's just abstract from all these complexities. And if you are in GKE and so on, then yeah, you need to be admin. Yeah.
For mirroring traffic, I mean, I assume there's a need to be for idempotent methods, right? You want mirroring traffic to credit to everything.
Yeah.
Is there a way to mirror traffic for non-sterile Kubernetes there?
For OpenShift? I don't know, without istio, right? Or I don't know. I don't think so. Yeah, I know that sounds weird, but I'm in the open source upstream side of the company. So I know Kubernetes, but not that much OpenShift. Yeah? So yeah, you are asking about that when you are doing the mirroring traffic, right? It's something that is provided by Istio. You don't need to do anything. Yeah, you just do, I want to mirror traffic. This is the main version. This is the mirrored version. And then automatically, Istio will just send the request to both services, but only the, I mean, I've got here the example. Well, and now I've not, it's not deployed, okay? But if you, backend source main Istio now, and it's here. What is the mirror? It should be somewhere here. Yeah, you see here. I'm just saying send always to v1 and mirror to v2. Then if I apply this, what you will see is that the bubbles are always red. But if you do a kubectl logs of the both deployed versions, you'll see that the version 2 still prints logs, because there is one. Well, this is something that I can show you. That's true. I can go here, kubectl logs. You see that there is this logs. So what you will see is that the ballots are red, but the logs in version 2 are printed, which means that the request is sent, but it just, Istio just takes the response and just throw away. Yeah.
So, again, mirroring traffic, is there a way to limit the traffic particularly like business transactions? Say I have like multiple regions, right? Everyone reads their safe.
So you want to limit? Yeah, you can limit. You can limit things. There is some ACL, I think it's called ACL rules, that you can limit the number of requests that you can send to ones to others. You can even, for example, limit the number of requests per second that you want to send, like bulk hit pattern. You can do things like that as well. This is the API that I want to allow, the rest not allow or something. Oh, so you would say that, I don't know. I don't know if I never thought about this specific use case. I know that Istio provides a plugin system with WASM plugins, so you can implement your own rules. So I don't know if it provides, let's say, already deployed things to do that, but if not, and it's something that you need, you can implement your plugins and just run them. But specifically, if it offers out of the box this specific use case, I don't know.